Hello, everybody. Here we are, 6.5 slope. Here are some notes. So the steepness of a line is defined as the slope. And I have a few definitions here, physical, graphical, and algebraic. So we'll fill in those blanks. And then I'll read a little definition. I'll show a few formulas. And then we'll go through a few examples. I like slope quite a bit. So a physical definition is the rate of change, how quickly or slowly something changes. Okay, so you can imagine something, the steepness of a slope or how flat something is. And graphical is the vertical change in, well, what do we expect? If we have our graph, our vertical up and down is our y's as x changes horizontally. So as x goes left to right and as y goes up and down. And algebraic, pretty similar to our graphical, but the vertical change in y divided by the horizontal change in x. So that kind of corresponds to some of the formulas that we'll see. So here's just a definition and some information that slope is the ratio of the vertical change, so the rise. This is kind of my favorite version of it, and its simplest form, just rise over run. So the ratio of the vertical change to the horizontal change, the run of a line or line segment. It is not expressed with units, so you're not really going to see 1/2 centimeters or anything like that. The slope is just something like 1/2 or 3/4 or 4 or whatever. It's often referred to as m in a formula. I couldn't really find a good explanation of why it's represented with an m, so if you find out, let me know. And so here are a few formulas that you might see to represent slope. My favorite kind of idea, I think at its simplest version, is just rise over run. This triangle here, so slope right here, m, slope equals the rise over run of a line. This triangle means change. So the change in y over the change in x. I think this little symbol is called delta. I think it's supposed to vaguely look like a D, but I don't know if it does. And another way to show it is y2, our kind of second y, subtract our first y over x2, subtract our x1. So this is mostly like if they, not always, but if they give us some kind of coordinates, so 4, 3, and say -1, I don't know, 2. I don't even know if those would work, but it's fine. Yeah, I think that would work. That this is our x, this is our y, this is our x, this is our y. And so it would be our, this would be, say, like our y2, our x2, our y1, our x1. So we would use this information, input it into our formula to find the slope of a line that passes through these two coordinates. So a few more, a little bit of information still, types of slope. We're looking at positive slopes, negative slopes, zero slope, and then undefined. So a positive slope moves upwards as we go left to right. And I say that it always, for me, I say that it moves like a check mark. Okay, so a positive slope moves like a check mark. A negative slope, as you go, left to right on our coordinate plane, it goes downwards. So that's a negative slope. It doesn't look like a check mark. Looks something like something else. And a zero slope is a horizontal line. You can imagine, so we're not really rising. We kind of have like a zero rise over, you can imagine any type of run. You could say it's 1 or 2 or 3 or 4. If you put this in your calculator, 0 divided by 1, you would get 0. And then if we have a vertical line, the slope is undefined. So this is all kind of rise over no run. So we maybe have something like 4/0. If you put that in your calculator, you'll get like an error sign, or it might say undefined. So if you're ever kind of not sure which one is 0 and which one is undefined, you pop it in your calculator, you should get the right answer. But, you could think about a flat line is not sloping up or down, and undefined is like it's all slope. It's all, straight up and down. So think about that. I think the best way for me personally to remember the positive slope is to say that it acts like a check mark, and the negative slope doesn't. That's, I think, the best way for me to do it like that, for example. So for number one, determine the slope of each line segment. I think G, H, and E, F might be our easiest to figure out, but let's go. We got A, B, we've got C, D, we have E, F, and we've got G, H. So I might, for all of these ones, just use my favorite way of figuring it out. I personally like rise over run. So we need to figure out for A, B, how much does it increase, or how much does it go up vertically over the run, over the change in our horizontal standing. So it looks like we go up 2, we rise 2. And so there's our 1, 2. And it looks like we run 1, 2, 3, 4, 5, 6, 2 over 6, or 1 over 3. And you can see the 1 over 3, also if we just did that, if we went up 1 and over 3, we would also find we get a little extra dot right there. So that's just our rise over run, a kind of simple way of showing that. For C and D, I'll do rise over run again, actually, because I want to show you something about our rise and run. So we start here. What's our rise? Well, actually, we're not, you can see we're not going upwards. We're going down 3. We're going down this way. So we went down 3 and then over 1, 2, 3, 4, 5. So to show that we've gone down 3 in our rise over run, I'd show that as a negative 3 over, and we went right 1, 2, 3, 4, 5 over 5. And so I want to point out that how do we know we're doing positive or negative? You could also remember this one isn't acting like a positive slope. This one acts like a check mark right here. Beautiful. This acts like a check mark. This one doesn't. So we know we're going to have a negative slope. Even if you just count the change, even if you just say it's 3, 1, 2, 3 over 1, 2, 3, 4, 5, if you did 3 over 5, you could then determine, oh, but I know it's a negative slope, so I'm going to put the negative with the 3. You could also put it with the 5. It doesn't matter. Either of those are acceptable. But I like to think about it personally as that if we have, our rise and our run, if it's up, it's positive, it's down, it's a negative. And our run, if it's right, it's positive, and left is negative. So you could think about it like that. You could think about, well, is the slope positive or negative? Do I need to put a negative on there? But you kind of get a little bit more used to it as we go. And I'll explain it as we go. And sorry, our next one, I erased it, but E, F. This is our straight up and down one, so this is undefined. And our G, H, it's not sloping at all. It's flat, and so that is a slope of 0. Okay, let's do a few more. We'll do, I think, a couple we'll use rise over run, and we'll also use some of our other formulas. So number 2, use a slope formula. It just says a slope formula, which is a good indication that you might be able to solve this kind of more than one way, to determine the slope of the line passing through each pair of points. So they've given us a handy graph. I'm going to start by graphing them. We have 2, negative 1. There's our A. And B is 1, 2, 3, 4. 1, 2, 3, 4, positive 4. Okay, so we have a line segment that passes through these 2 points. Okay, so we could, and maybe I'll do both. We can maybe just do a simple kind of rise over run. And it looks like our rise, it's going to be a positive slope because it's moving like a check mark. So it looks like our rise, we go up 1, 2, 3, 4, 5, and we run 1. So 5 over 1, or 5. And let's use our other formula. So we have this other way of determining our slope, y2 subtract y1, 1, over x2 subtract x1. And so let's figure that out. Here we have our y2, so our second y. Remember, this is the x, the y, the x, the y. So our second y is 4, subtract our first y, -1, over our second x, 3, subtract 2. And then what did we get? 4 subtract -1 is like 5, and 3 subtract 2 is 1. And there we go, we got the same answer. So let's do our -1. Or sorry, our next one. I don't know if it's going to be negative. Here, let's do it. Let's graph it. We have 0, 7, 1, 2, 3, 4, 5, 6, 7, all the way up here, C. And then -3, 7, 1, 2, 3, and 7 is going to be there as well, D. So, I mean, what do we see? It looks like we have a straight line. So I would say the slope of this is, remember, our horizontal lines are the slope that's 0. So m equals, keeps doing that, m equals 0. You could, if you want, use our other formula, y2 minus y1. So we could go 7 minus 0 over -3 minus 7. What, have I done this right? No, I haven't. I have not. That doesn't look right. So here we go. Here's our x, here's our y, here's our x, here's our y. Okay, so now we got 7 minus, there we go, 7. That makes sense. Over, there we go, -3 minus 0, which ends up with 0 over -3, which is 0. So you can do it either way. I think it's good to memorize what the 0 slope looks like and what an undefined looks like. So I think there's a kind of quicker way to do that, but you could always use that one if you'd like. And now let's do number 4. I like to use rise over run for this. And I think for these questions, it's always best. So it wants us to graph each line given a point on the line and its slope. So it's best to start always with our point. So let's graph our point. We're at 1, 2, 3, 4, and 1, 2, 3, 4, 5. So we're starting here. And now we have our slope, which is 3. So m equals 3. And don't forget, all numbers can have an invisible little, it could be over an invisible 1. So this means this is our rise over our run. So from here, we can rise. I mean, we're going to be off the chart. 1, 2, 3, and run 1. So we're going to go up. That's positive is up, and right right is positive. So it's the positive slope. We want to move like a check mark. The way to go the other way, we should know that 3 over 1 is equal to -3 over -1. So we can also go down 3, 1, 2, 3, and left 1. Down 3, 1, 2, 3, and left 1. So there you go. Our line looks something like that. Okay, and it does have a positive slope. 3 is a positive slope. Our line moves like a check mark, so that's good. And then let's do our other one. Maybe I'll use another color, red. Let's start at our point. So we know this point for sure is on our line. It's at -2, 6. So -2, 1, 2, 3, 4, 5, 6 up here. And then our slope is 1 over 2. So we rise 1 and run 2. It's positive as well, so we expect to move like a check mark. We're going to rise 1 and run 2. Start right there. Instead of going off the chart, let's go down one. So let's go -1 over